Today we will discuss about dispersion of light and scattering of light, and of course later we will discuss about the optical instruments. So what is the dispersion of light? Dispersion of light. When a composite light like white light passes through a prism-like device or a transparent medium that can refract light, the component colors in the white light get refracted by different angles, and hence the emergent light consists of a pattern of colors. So if white light is incident like this, so it splits into its component colors. So you will be getting 7 colors that already you learned in your lower class. Suppose this is red, this is violet, indigo, blue, green, orange, yellow, red. So violet, indigo, blue, green, orange, yellow, red. So into such 7 colors, distinct colors, the white light gets dispersed by the prism material. So this you might have studied in lower class. So a composite light getting dispersed or splitting into its constituent colors is called as dispersion of light. This happens because the refraction of different colors is different in a medium. It means the waves of different colors travel with different speeds in a medium other than vacuum or air. Whereas in vacuum or air, all colors, that is all electromagnetic waves, travel with the same speed. But in other media, they travel with different speeds. So splitting of constant colors in a composite light by refraction is known as dispersion. Since they deviate by different angles, you observe the pattern of colors in a sequence. This pattern of colors in a sequence is called as spectrum. So a spectrum is the sequence of colors, means they are in an order. So either increasing order of their wavelength or decreasing order of the wavelength. If they are arranged, then we call it as electromagnetic spectrum. So in the electromagnetic spectrum, the visible light is a very small part. This we will study in another chapter when we study about electromagnetic waves. And dispersion is happening because of the medium, because of refraction. That was proved by Newton. He kept another prism like this in the inverted position just beside the first prism. Then he observed that all the colors merged together and we got white light. So he proved that white light consists of all the colors. In that way, he proved that dispersion phenomena is happening because of the refraction phenomena. Okay, so there are several observations we can discuss in nature. One is formation of rainbow. A rainbow is an example of dispersion of light by water droplets present in the atmosphere. And what happens means when it rains or when there is suspended water droplets are there in the atmosphere, the light coming from the sun passes through the droplets and dispersion takes place. So it can be explained like this. Let us suppose this is a water drop. So a light incident like this after refraction and reflection inside the water drop. So if this angle of incidence is greater than the critical angle, it gets totally reflected. So the reflected ray disperses after dispersion, because it is undergoing diffraction and splitting into colors. I am showing only one ray here. So when it comes out, the different colors will come out by different angles of refraction. So first of all, what we get is this is say the red and this is violet. So like that, from the next droplet, suppose the light getting refracted like this. So red is coming like this, violet is coming like this. For an observer, he sees the red color on the top and violet color at the bottom. So you can observe a rainbow, which we call it as primary rainbow. Primary rainbow. So you will see first that red color and at the bottom violet. Of course, the visibility of violet is a bit less, but still you can see. So like this, you can explain the formation of rainbow by dispersion of light due to the water droplets. Here there is here there is a refraction, here is a reflection, and again here is a refraction. So two refractions and one reflection is responsible for the formation of primary rainbow. Sometimes you might have seen secondary rainbow. That secondary rainbow is formed due to two times reflection inside the water droplet. Suppose a ray is incident like this, so it gets reflected from here, it gets reflected again here. So therefore, we will be netting the rays out after second reflection. Due to the second reflection, what happens is the colors are inverted. So first you see violet, then the other colors, and at the bottom you will get the red color. And also, due to two reflections, some light is absorbed in the process. Hence, intensity of the second rainbow is lesser than that of primary rainbow. So this is one observation in nature of this dispersion of light. And now we will discuss about scattering of light by the atmospheric particles. So scattering means here scattering means certain wavelengths of the composite light are scattered by the atmospheric particles more than the other wavelengths. So according to Rayleigh formula, the quantity or the amount of scattering is inversely proportional to the fourth power of wavelength of light. So according to that, if the size of a particle is far less than the wavelength of the light, then that wavelengths are more scattered. So the scattering will be proportional to 1 by lambda power 4. So suppose if the size of the atmospheric particles is greater than the wavelength, then such particles will scatter all the wavelengths equally. Therefore, you won't see any special effect due to this type of scattering. So the that particle or dust particles whose size is smaller than the wavelength are responsible for scattering the blue wavelength in the white composite light coming from the sun. So that is the reason for the blueness of the sky. Though the violet has very less wavelength compared to the blue color, but due to the visibility of light, because our eyes are more sensitive for blue color than violet, that's why though the violet color is scattered more than blue light, but since our eye is sensitive to that color, we see that blueness. And similarly, we can explain the redness or the hue during the sunset or sunrise. Similarly for the moon also, when it rises, it appears red. The reason is nothing but at the horizon, when the sun is at the horizon, the light coming from the sun has to travel a longer distance through the atmosphere. Therefore, most of the shorter wavelengths are scattered. Only the longest wavelength waves, that is red light, reaches the eye. Therefore, the sun during the rising or setting appears red. So, in that way, we can discuss about the scattering of light. Okay. Now, we will go for that optical instruments, optical devices such as working of a microscope, telescope, etc. Okay. So, before going to the actual optical instruments, first discuss briefly about the eye. Eye is also an optical device which nature provides us. So, you know that we are able to see the objects because of the light reflected from the objects reaches our eye. When I was studied in biology about the structure of eye. So, eye consists of the cornea that curves the face, and then behind that you have that pupil, which is the central hole of iris. So, through this pupil, light passes through the crystalline lens, and the image is formed on the retina, which is made up of nerve fibers. So, it consists of rods and cones, which respond for the intensity of the light and color of the light. So, these rods and cones, they detect the intensity and color of the light falling on the retina. They convert these visual signals into electrical signals and electrical pulses, and through the nerves, optic nerves, it passes through the brain where it is processed. The image feeling is given to us. So, the image formation by the eye and the sense giving that, the senses giving the sense of image is actually a complex process. And we know that depending upon the distance of the object we are seeing, the focal length of the eye changes. So, with the help of the ciliary muscles, the curvature of the eyelids is slightly modified. Therefore, the distance between the lens and the retina is kept constant, but the focal length of the eyelids slightly changes. And let us discuss about what is the least distance of distinct vision and what are the defects of eyes, how they are corrected, and then later we will go for the microscopes and telescopes. The image formed by the eyelids on the retina, which is nearly at a distance of 2.5 centimeters. So, we can say for normal vision, the eyelids has a focal length of this. So, you can easily test yourself that when you bring an object nearer to the eye, you can see this clearly the object when it is at a distance of 25 centimeters from your eye. So, this is called as least distance of distinct vision. Least distance of distinct vision. So, this if the object comes nearer than this distance, since the focal length of the eyelids cannot be adjusted by the ciliary muscles, we will feel a strain in the eye. And due to this limited distance up to which we can see clearly, persons who are about 60 years or so, their distance of clear vision, minimum distance of clear vision increases because the muscles lose their ability to adjust the focal length of the eye. Hence, they cannot see nearer objects, they can see only distant objects. So, their least distance of vision may change even up to 200 centimeters or so. So, therefore, they require a converging lens, a convex lens for such vision. So, such type of defect is called presbyopia. To correct it, convex lenses are used. Now let us discuss some general eye defects and how to correct them. Defects of and correction. So this is a very important topic from 2 marks questions point of view. So eye defects are mainly 2 types. One is short sight, the other is long sight. Suppose say this is your eye and this is the iris. So if the light coming from the distant far away object, suppose here is the object, so light coming from this is focused in front of the iris, in front of the retina. So say suppose this is the retina. So the image of the object is formed in front of the retina, hence the person cannot see it. So the focal length is lesser than the normal value. So to increase the focal length such that the image is formed exactly on the retina, between the object and the eye lens, a concave lens is interposed of suitable focal length. Therefore, you will be getting the image focused because the effective focal length increases, thereby the image is formed on the retina, hence the person can see clearly. So this defect is called as myopia or short sight. So to correct myopia or short sight, a concave lens is used with suitable focal length. And another defect is like this. Let us suppose this is here. This is the iris. So the rays coming from the object, if they get focused behind the retina, so here they may get focused. So that means due to larger focal length of the eye lens, the final image is formed behind the retina. So to correct this image, to decrease the focal length, suitable convex lens is interposed between the eye lens and the object. So the final image is formed exactly on the retina. So this type of defect is called as hypermetropia. Hypermetropia. And also known as long sight. And using a suitable convex lens, the defect can be corrected. So other than these 2 types of defects, there is another defect known as astigmatism. So this astigmatism arises due to defect in the curvature of the pupil, or there is the curvature is responsible for that astigmatism, because the grid lines, either vertical or horizontal, one of them cannot be focused correctly. Therefore, a person with this astigmatism can see either horizontal lines or vertical lines. One set of lines appear to be curved. So to correct this type of defect, a cylindrical type of lens with a suitable axis is used for correcting astigmatism. Some persons may have both myopia and astigmatism, or hypermetropia, astigmatism. So they have a combination of 2 types of lenses for correcting such type of defects. Other than this, another defect is there, that is color blindness, which is a biological defect caused by nervous system. So that cannot be corrected using lenses. So as that color blindness is inability to distinguish colors. Okay, so that is about eye defects and their correction. Then we will go for the optical instruments such as microscopes and telescopes.